Hello everyone. Today we're going to be learning about CMOS circuits. So CMOS, or complementary metal oxide semiconductor circuits, are circuits made up purely of MOSFET transistors used to achieve various logical functions. Now, these MOSFET transistors are categorized into two main categories, those being the NMOS and the PMOS transistors. So let's take a look at the NMOS transistor first. So here we have two symbols for an NMOS transistor. Both are interchangeable. They each have a gate, drain, and source, and they are of the P-type substrate. So we can make a truth table to map the behavior of these transistors, where our input is applied to the gate of these transistors. So firstly, if we apply 0 or ground or 0 volts to our gate, this transistor is off and there is no connection made between drain or source, resulting in an output of 0. Whereas if we apply an input of 1 or say 3.3 volts to the gate, this transistor is on and there is a connection between the drain and the source. So our output will be 1. Now let's take a look at the PMOS transistor. Again, two symbols for PMOS, both are interchangeable. They each have a gate, drain, and source similar to the NMOS. However, these are of the N-type substrate. So again, we can make a truth table where our input is applied to the gate. So if we input a 0 or ground at the gate, this PMOS transistor will be on, and there will be a connection from drain to source, resulting in an output of 1. Now, the flip side, if we input a 1 on the gate, or say 3.3 volts, this transistor will be off and there will be no connection between drain and source, resulting in an output of 0. Okay, now one other concept we need to touch on are AND and OR logic. So anytime you have transistors in series, like so, this is equivalent to AND. So say we have inputs X and Y and we have a signal here. In order for that signal to get down to here to whatever other circuit you have, you need both X and Y to be on, right? So we need 1, 1 here. So if X is 1, this signal can travel through this first transistor here. But if Y is 0, this transistor will be off and there's no way for this signal to get down here. However, if Y is 1, then it can keep traveling through here and get to the other circuit down here. So transistors in series are and transistors in parallel, like we have over here, are OR. So again, say inputs X and Y, and we have our signal up here, and we want it to get down here to some other circuit. If X is high, and this NMOS is turned on, the signal can travel through here and find a path down here, regardless of what Y is. And vice versa. If Y is 1, the signal has a path to travel through here and get down here, regardless of what X is. So transistors in series are and transistors in parallel are OR. So let's look at one CMOS circuit example here. I've got our inputs X and Y mapped out here, and our output Z. I'm just going to go through each independent input and map the corresponding output. So for input 0, 0, we'll see that these two PMOS transistors are on, which connects VDD down here to this node, which goes to the gate of these two transistors, which turns this NMOS on, connecting our output Z to VDD, resulting in an output of 1. Now for input 0, 1, this top PMOS up here is on, but this PMOS with the input Y on it is off, so there's no connection made there. However, this Y transistor, this Y NMOS transistor, is on, thus connecting our ground to this node up here, which goes to the gate of these two transistors, turning this PMOS on and connecting our ground to our output Z, resulting in an output of 0. Now on the flip side, for input 1, 0, this top PMOS up here is off, so no connection made there. However, this NMOS is on right here, which connects our ground to this node up here, going to the gate of these two transistors, thus turning on this PMOS, and that connects ground to our output Z, resulting in an output of 0. And lastly, for input 1, 1, both these two top PMOS transistors are off. No connection is made from VDD down here. These two NMOSs down here are both on, which connects ground to this node up here, going to the two gates of these transistors here. That turns this PMOS on, which connects ground to Z, resulting in an output of 0. And what we have here, as we just verified, is a NOR gate CMOS circuit.